Our solar system is a place of incredible diversity and wonder. Further out, we encounter gas giants like Jupiter and Saturn, ruling their own mini-systems of moons and rings. Among these icy companions, one moon stands out for its peculiar characteristics and intriguing mysteries. A small faint moon named Naiad. Neptune's moon system is a complex and dynamic environment shaped by the gravitational forces of both the giant planet and its numerous moons. 14 moons are officially recognized, ranging in size from the massive Triton, larger than Pluto, to tiny irregular moons barely a few kilometers across. Naiad, despite its small size, is not immune to these powerful forces. In 1989, as the Voyager 2 spacecraft hurtled towards its closest encounter with Neptune, its cameras captured a faint, previously unknown moon orbiting close to the gas giant. This newfound moon, later named Naiad after the water nymphs of Greek mythology, was a significant discovery. Naiad, although small and faint, became a piece of the puzzle in unraveling the mysteries of this distant ice giant. The discovery of Naiad, like many scientific breakthroughs, was a testament to meticulous planning, advanced technology, and a touch of serendipity. Amidst the grainy images and faint signals, a pattern emerged, a series of dots that didn't quite fit with the known moons of Neptune. Further analysis confirmed their suspicions. Voyager 2 had stumbled upon a new moon, later named Naiad. Voyager 2, with its suite of scientific instruments, provided our first and, to date, only close-up glimpse of Naiad. Despite the brief encounter, Voyager 2 managed to capture enough data to provide rudimentary information about Naiad's size, shape, and orbital characteristics. Naiad's orbit was determined to be nearly circular, inclined by a mere 4.7 degrees relative to Neptune's equator. Despite the valuable data gathered by Voyager 2, our understanding of Naiad remains frustratingly limited. Its small size and immense distance from Earth make it an incredibly challenging object to study from the ground. Even the most powerful telescopes struggle to discern any details on its surface, leaving us with more questions than answers. In the decades since Voyager 2's flyby, no other spacecraft has visited Neptune or its intriguing system of moons. To truly unravel the secrets of this enigmatic moon, we need another mission, a dedicated spacecraft equipped with advanced instruments capable of piercing the veil of distance and faintness. Until that day arrives, Naiad will remain a tantalizing enigma, a faint whisper from the outer reaches of our solar system, beckoning us to return and uncover its secrets. Imagine a celestial body so small it could fit comfortably within the boundaries of a large city. Despite its diminutive size, Naiad holds its own in the grand cosmic ballet around Neptune. The surface of Naiad, as glimpsed by Voyager 2, is incredibly dark, reflecting only a meager 6% of the sunlight that reaches it. One of the most intriguing aspects of Naiad is its shape. Unlike many large moons, which tend towards sphericity due to their own gravity pulling them into a round shape, Naiad is distinctly elongated, resembling a celestial potato more than a perfect sphere. The dark, cratered surface of Naiad further supports the notion of a violent past. Naiad, like all celestial objects in our solar system, is engaged in a delicate cosmic dance, its movements dictated by the relentless pull of gravity. Orbiting Neptune at an average distance of approximately 48,200 kilometers, It completes one orbit around the ice giant in a mere 7 hours and 6 minutes. This near-circular orbit suggests that Naiad formed within the gravitational influence of Neptune. While Naiad's orbit might seem simple at first glance, it's actually part of a complex and fascinating gravitational interplay with other moons in Neptune's system. Specifically, Naiad is locked in an orbital resonance with its larger sibling, Thalassa, a moon orbiting slightly farther out from Neptune. This delicate balance of gravitational forces highlights the intricate and interconnected nature of celestial mechanics. In the vast expanse of our solar system, gravity reigns supreme, orchestrating a celestial ballet of planets, moons, and countless smaller objects. Each celestial body, from the mightiest star to the humblest asteroid, exerts a gravitational pull on every other object, creating a complex web of interactions that governs their movements. Naiad, despite its diminutive size, is no exception. This tiny moon, caught in the gravitational embrace of Neptune, participates in an intricate dance with its planetary host and its fellow moons. Imagine Naiad, a celestial minnow, navigating the gravitational currents generated by Neptune, a colossal celestial body 17 times the mass of Earth. Neptune's gravity, like an invisible tether, keeps Naiad bound in its orbit, dictating its path and influencing its fate. But Neptune's gravitational influence extends beyond simply holding Naiad in its grasp. It creates tidal forces, a difference in gravitational pull across Naiad's diameter, that subtly squeeze and stretch the moon's interior. These tidal forces, though seemingly insignificant compared to the overwhelming force that binds Naiad to Neptune, play a crucial role in shaping the moon's destiny. Over eons, they can generate heat within a moon's interior, potentially leading to geological activity, such as volcanism or the formation of subsurface oceans. In some cases, tidal forces can even tear a moon apart if the gravitational forces exceed the moon's structural integrity. While Neptune's gravity dominates Naiad's existence, it's not the only gravitational force at play. In the intricate choreography of celestial mechanics, Naiad also interacts with its neighboring moons, particularly its closest sibling, Thalassa. These interactions, though subtle compared to the overwhelming pull of Neptune, add another layer of complexity to Naiad's story. Naiad and Thalassa are locked in what's known as an orbital resonance, a celestial dance where their orbital periods, the time it takes them to complete one orbit around Neptune, are related by a ratio of small whole numbers. In this particular cosmic ballet, for every 73 orbits Naiad completes, Thalassa completes 69. This resonance, though it might seem like a mere mathematical curiosity, has profound consequences for both moons. Imagine Naiad and Thalassa as two dancers, circling a grand ballroom, their movements synchronized yet distinct. As they waltz around Neptune, their gravitational tugs on each other, though weak, occur at predictable intervals due to their resonant orbits. These periodic tugs act as gentle nudges, preventing either moon from straying too far from its designated path. This delicate balance of gravitational forces ensures that Naiad and Thalassa can coexist in relative harmony, their orbits remaining stable over astronomical timescales. Tidal forces, those subtle differences in gravitational pull across a celestial body, act as invisible sculptors, shaping the destinies of moons throughout our solar system. Naiad, despite its small size, is not immune to these powerful forces. Over billions of years, tidal interactions with Neptune have left their mark on this tiny moon, influencing its shape, rotation, and potentially even its internal structure. Imagine Naiad, a celestial dough being kneaded by the invisible hands of Neptune's gravity. As the moon orbits the giant planet, tidal forces gently stretch and squeeze its interior, generating friction and heat. This tidal heating, though less intense than what some of Jupiter's or Saturn's moons experience, can still have a significant impact on Naiad's evolution. Over time, Tidal heating might have played a role in shaping Naiad's elongated, irregular shape. The constant push and pull of Neptune's gravity could have prevented the moon from settling into a more spherical form, leaving it as a celestial potato, a testament to the relentless forces at play. Tidal stresses might have also created internal fractures and voids within Naiad, weakening its structural integrity and potentially making it more susceptible to fragmentation in the event of a major impact. Despite the insights gleaned from Voyager 2's fleeting encounter and subsequent observations from Earth-based telescopes, Naiad remains a tantalizing enigma. Its small size, faintness, and immense distance from Earth continue to shroud this tiny moon in mystery, leaving astronomers with more questions than answers. Unraveling the secrets of Naiad's past and predicting its future require more detailed observations, perhaps even a dedicated mission to this distant world. One of the most pressing questions surrounding Naiad is its internal composition and structure. Is it a solid body, composed mostly of ice with perhaps a small rocky core? Or is it a rubble pile, a loosely bound collection of smaller objects held together by their own weak gravity? Answering this question would provide valuable clues about Naiad's formation and its collisional history, shedding light on the chaotic early days of the solar system. Another mystery surrounds the possibility of past or present geological activity on Naiad. Could tidal heating have generated enough internal heat to melt some of the moon's ice, creating a subsurface ocean in its distant past or even today? While such a scenario seems unlikely given Naiad's small size, it's not entirely out of the realm of possibility. If a subsurface ocean did exist, it could potentially harbor conditions suitable for life, adding another intriguing chapter to Naiad's story. Peering through the vast cosmic distances at a moon as small and faint as Naiad is akin to trying to discern a single grain of sand on a distant beach. Our current understanding of Naiad is built upon a foundation of limited data, a few precious pixels transmitted across billions of kilometers by Voyager 2, and the faint echoes of light captured by Earth-based telescopes. Yet, despite these limitations, scientists have been able to piece together a tantalizing, albeit incomplete picture of this enigmatic moon, revealing a world shaped by both familiar and alien forces. Imagine trying to understand the history of Earth from a single blurry photograph taken from space. You might be able to discern the outlines of continents, the swirls of clouds, and perhaps even the glint of sunlight reflecting off the ocean. But the intricate details, the bustling cities, the lush forests, and the vast deserts would remain hidden from view. Such is the challenge faced by scientists studying Naiad. Despite the limitations, each new observation, each analysis of existing data brings us one step closer to unveiling Naiad's secrets. By studying its orbital characteristics, its interactions with Neptune and other moons, and the faint light reflected from its surface, scientists can begin to piece together the story of this distant world, a story that spans billions of years and encompasses the birth and evolution of our solar system. Naiad's surface, shrouded in twilight, remains hidden. Voyager 2 revealed a dark, ancient surface, but details are scarce. Scientists guess Naiad's surface is cratered, like other icy moons, from billions of years of impacts. Its low albedo suggests dark organic molecules or minerals. Cryovolcanism, seen on Triton and Enceladus, might be possible due to tidal heating. In the vast cosmic ballet of our solar system, Naiad might seem like a solitary dancer, gracefully waltzing around Neptune in relative isolation. However, appearances can be deceiving. Astronomers have long suspected that Naiad might not be alone in its dance, but could be part of a more complex and intricate choreography, sharing its orbital neighborhood with a retinue of smaller, fainter companions. These hypothetical companions, too small and faint to be easily detected with current telescopes, could be remnants from the early solar system, fragments of larger moons torn apart by collisions or gravitational interactions. They could also be captured objects, asteroids or comets ensnared by Neptune's gravity and drawn into orbit around the planet. The presence of such companions, even if extremely small, could have significant implications for Naiad's evolution. Their gravitational tugs, though subtle, could influence Naiad's orbit over time, potentially contributing to its elongated shape or even triggering episodes of resurfacing. They could also act as sources of impactors, showering Naiad with a steady rain of dust and debris that could alter its surface composition and reflectivity. The search for Naiad's unseen companions is a challenging but potentially rewarding endeavor. Future missions to Neptune, equipped with more sensitive instruments, could shed light on this hidden population of objects, revealing the true complexity of Naiad's orbital environment and providing valuable insights into the formation and evolution of planetary systems. As we peer into the future of Naiad, this tiny enigmatic moon continues to beckon us from the distant reaches of our solar system. Naiad will likely continue its celestial dance around Neptune for billions of years, shaped by gravitational influences and potential impacts. To unravel Naiad's mysteries, we need a dedicated mission with advanced instruments. Until then, Naiad remains a tantalizing enigma in planetary science. In the grand tapestry of our cosmos, Naiad might seem like an insignificant speck, a tiny moon dwarfed by Neptune and the vastness of the universe. Yet, like every celestial object, Naiad holds a unique place in the cosmic order. Its discovery expanded our understanding of planetary systems and fueled our curiosity about distant worlds. Naiad's existence speaks to the boundless creativity and diversity of the cosmos. Even the smallest objects can hold profound secrets. Our exploration of the outer solar system has been a journey of profound discovery. Each mission reveals a universe far more complex and awe-inspiring than we could have imagined. Naiad has contributed significantly to our understanding of planetary formation and orbital dynamics. From Voyager 2, we learned Neptune harbors a retinue of moons, each with its own story. Naiad is an active participant in a delicate gravitational dance with Neptune and its moons. Its dark, cratered surface hints at a violent past shaped by collisions and gravitational interactions. Naiad continues to hold many mysteries close to its icy heart. The exact composition of its surface, the possibility of past or present geological activity, and the potential presence of unseen companions remain open questions for future exploration. These unanswered questions remind us that our journey of discovery is far from over. The outer solar system still holds many secrets waiting to be unlocked. As we stand at the precipice of a new era of space exploration, fueled by technological advancements and an unquenchable thirst for knowledge, the outer solar system beckons us with the promise of untold discoveries. Missions currently in development, such as NASA's Europa Clipper, and potential future missions to Uranus and Neptune, hold the potential to revolutionize our understanding of these distant worlds and their intriguing retinues of moons. Imagine a future mission to Neptune, equipped with instruments capable of piercing the veil of distance and faintness that currently obscures Naiad from our view. Such a mission could map the moon's surface in high resolution, revealing the intricate details of its craters, its composition, and potentially even signs of past or present geological activity. A lander, dispatched to Naiad's surface, could analyze its icy soil, searching for organic molecules or other hints of the building blocks of life. The prospect of exploring Naiad in greater detail is not merely a scientific pipe dream, but a tangible possibility within our reach. As our understanding of the outer solar system grows, so too does our desire to venture further into this uncharted territory, driven by the allure of the unknown and the fundamental human urge to explore. Naiad, with its enigmatic beauty and its tantalizing secrets, awaits our return, a beacon in the cosmic darkness, beckoning us to unravel the mysteries of our cosmic origins and the boundless possibilities of the universe we inhabit.